So I want to make one quick point because I think maybe Deborah was too polite to mention it. So what's important from at least through the last year, right? The data center industry actually thinks they've been doing an excellent job with this environmental stuff, right? Because they've done a lot of investments in renewable energy, right? So when they aren't using, solar energy from the roof of their data centers, then they're buying carbon credits and someone else is taking care of it kind of on the back end. So the data center operators, if you ask them or if you read their ESG reports, they actually think they're doing a really good job with the whole renewable thing, right? Because they're focused on the energy consumption, the operational use, as was in Deborah's slides, and until recently, until a set of us and some folks have been doing this longer than I have been making noise about, there's all this embodied carbon, all this embodied energy, right? So this kind of an important point is that there was a bit of a wake-up call, right? And Deborah's already motivated all the resources and so on that go into our beautiful containers when we're doing software. And then in another talk, at other events, at software events, I spend a lot more time on this, but we can safely talk about hardware here. But just remember, the software folks also kind of usually pat themselves on the back of, we've been doing such a great job, we're saving the world, we're doing vaccines, we're curing cancer, we're doing AI, well, maybe it's a little creepy, but mostly it's okay. Ads pay for it all, but maybe that's okay, whatever. But it is important that this is true, right? That the advance of computing, right, kind of in my career lifetime and in the lifetimes kind of everyone here, has made incredible progress, right? And nothing that we're saying should take away from this, right? And what we're really saying is that hey, some inefficiency has crept into this whole process, right? And if we're just a little bit careful, then we can still kind of save the world and kind of save the world, right? Or not destroy it on the back end, right? And so here, just a quick shout out, there's an organization, the Green Software Foundation, that's looking at making software more efficient, right? And that is kind of the input at the top of the stack, right? If the software demands less from the hardware, then the hardware has to produce less, right? So there is a bit of a hierarchy here. And so this is how I often try to describe kind of that the openness, right? It's the point of our event here, is necessary, but it's not sufficient because there is this wide range of engineering that has to take place, right? Kind of the silos that I allude to in the title of the talk, right? And so hardware has to be designed, engineered, quality, reliability, like all these things that we've invested in the last 20, 25 years in the computing industry, right? I used to work at Seagate, where when I was at Seagate factories produced one hard drive every 3 seconds. Right? And this was done with massive investments of robotics and technology. So it was technology in the drives themselves. It was technology in the manufacturing processes. Right? An incredible amount of things that we've brought to bear. It's all excellent, right? Then similarly in the software world, right? So, if one hard drive a second is amazing to you, right? One ad served or 1 million ads served every millisecond, right? Is the metric for software folks. But there is also design and rigor and reliability and so on in that area, right? And then what I've found in my career, kind of spanning these two areas, it's just this huge dynamic range of skills. Right? And as I say it here, from capacitors to the CAP theorem to cognitive load in user interface design, right? So computing is this massive array of expertise. And I think one of the things that I've experienced is that often it's fine for us to specialize in our silos, but occasionally it means that we create ossified kind of inefficiency for the next layer down. And I think server design, in the way that Astrid talked about, creates a number of those barriers. Right? Until maybe 2 years ago, the size of a disk drive was determined by how big your desktop computer used to be 15 years ago when you were still using a desktop computer, right? Basically ludicrous from a design perspective, right? So there is this partnership, I think, that's necessary, and this cross-silo communication, right? And so now I want to stop being negative. Now I wanted to be positive in this. And so one of the things that we've done, Lesia talked about it this morning, the Open Compute Project, is now 10 years old, just over 10 years old, and I've been involved from since the early days. And what we've tried to do is bring some of the openness and the collaboration, the worldwide collaboration, the cross-silo collaboration to hardware that existed in the software space. It's just software, you just download it, and it's the same for everyone all over the world, whoever can reach GitHub. But bring that also to hardware, right? And this has been successful. So there are millions, tens of millions of open compute design servers in the world today, creeping on you. It's solving problems all over the world for you, right? And there's a range of form factors and so on, right? But then I just want to make one kind of point here about kind of hardware versus software, so that it's quite related, right? When I say GitHub and so on, but there is sometimes a bit of nuance, and I think it's relevant to some of the design choices that end up getting made. That happen in hardware that maybe doesn't happen as much in software. So in software, the GitHub is the ground truth, right? That's the source code. That's what the code currently is, right? It turns out in hardware, it's not always the case, right? And the example I use here is from traditional building architecture. But when you think about the as-built plan, right? So anyone who's owned a house or tried to own a house or had a relative who owned a house, they know that there's a big difference between what the architect's plan was and what has actually been put into the ground. Right? Or into a large convention center like this, right? And let me give you a concrete example from our experiences with OCP. So one of the great things about OCP is that all of the design files and the design materials are made available in the open. So this is the CAD drawing of a rack, an OCP rack, as it was designed. And as part of our business at my most recent company, I'll show that in a second, we were working with these racks, and we wanted to make a modification. So we wanted to increase the density of this rack system. And so what we wanted to remove this crossbar here. And on the CAD diagrams, there is a set of screws on both sides here, some bolts and the things. So we told our folks in the manufacturing facility, just take out these bolts, take out this crossbar, and then we'll work with it, right? And the folks in the U.S. Kind of weren't responding to us because they were too polite. And eventually, our folks in Sweden were like, "What are you guys talking about? You're crazy. We can't do this thing." And we said, "What do you mean? You just take out these bolts, right? You don't have the right screwdriver. Like what? You need some kind of hex thing, Torx, whatever, right?" And they're like, "No, it's welded," right? And so what happened is, right, someone at the rack manufacturer, right, took this design and they created this crossbar, and they shook it a little bit maybe, or maybe they just looked at it funny and decided, it's not strong enough here with these bolts, right? And someone else is like, just weld it, a little bit of energy, apply a little bit of energy, melt a little bit of the steel, and you weld it together like this. And it becomes stronger, totally true, right? So maybe that was a design mistake. Maybe whoever made these CAD, the committee that stood around, maybe they weren't thinking carefully enough about, what might happen. But importantly, the welding people didn't tell the diagram people to update it, right? And so this became kind of a problem for us in this project. We eventually figured out another way. But undoing this weld is super expensive in terms of, it wasn't designed for that and so on, right? Which our friends in Sweden quickly told us when we said, "Hey, can't you just get rid of the weld?" And they're like, "You nutters in America," right? And so the reason it matters is, so this is a picture of the processing facility in Kansas for my most recent employer, IT Renew. So this is a warehouse full of OCP servers that are on their way to being recertified, right? So this is at least probably 300, 400 racks here. And just to give you a sense of the scope, right? So the IT Renew facilities, there's 10 facilities worldwide, will process between 35,000 and 100,000 servers per month in a recertified, in a recycling, decommissioning sense, right? So IT Renew has contracts with 3 of the 5 largest hyperscalers, in some case exclusive contracts. So the amount of material flow is just amazing, right? And as Astrid, I think Deborah quoted the same number, so that 20% reuse, right? So if we could, and we are, so this facility is doing somewhere on the order of, depending on the server and so on, somewhere in that neighborhood of 20%, maybe 10 to 30% reuse. But if we could bring that reuse number from 20% to 30%, it would mean 50% more of this material that doesn't go down the very negative pathways that that Deborah described, right? The recycling, or kind of worst case, kind of a landfill model, right? And our estimation at IT Renew is that if we took just 30% of the total material, we would have sold more servers last year than Lenovo, right? So this is a very, very big process, right? But it also kind of, in the corners, it kind of looks a little bit like this. So there's definitely also a sorting and a binning and a process to doing this recertification process. I can go into that kind of another time, right? But so the important thing is that by taking a little bit of extra care in the design, in the ways that Deborah talked about, right? Designing for circular, or just designing for simplicity and designing for cost, really gets a big win, right? And this is what OCP has shown, right? So the OCP project that Lesia talked about this morning, 10 years all told. This is the set of current kind of sponsor companies, or maybe 12 months ago, sponsor companies. Importantly here, there's individual vendors, component vendors, right? Some of the hard drive companies, for example, Intel. There are system vendors, and there are also end user companies on here, right? You see AT&T, Meta, ByteDance, for example, right? Very important in an industry body to have the end users as well as the creators, kind of the integrators, and the original engineers, right, involved. And then a very wide range of projects, right? I just want to talk about one set here. So these server designs, right? So those 65 server design projects at the beginning, they were, most of them, conceived specifically with the idea of reducing the complexity, increasing the commonality of the servers that are built in order to reduce cost and resource consumption. They weren't, until very recently, thinking about the circularity, the kind of reuse aspect, but they were just thinking about, if I have it use less plastic, then I don't pay for as much plastic, right? If I have it use less metal to accomplish the same thing, or less different kinds of metal, right, then it costs less, and maybe it consumes less energy if the metal is inside a power supply or something like that. And so super important that one of the guiding principles of many of these designs was simplify to the just as much functionality and so on as is necessary, and not, so Andy Bechtolsheim, who was one of the originators of OCP, talked about it as gratuitous innovation, right? And if you take three servers, as Astrid showed, next to each other, you'll see gratuitous innovation writ large. So very important that we've been able to, with real investment, real projects, real, sometimes 4, 5, 6, 8 companies sitting around, and sitting around a table to work on a design. And the open aspect of this is so important, right? I wanted to mention it in answer to one of the questions earlier this morning. The first OCP meeting I attended in New York City, I guess I said almost 10 years ago, there was a couple of friends of mine who are also architects in other parts of the ecosystem, and we stood around, and they wanted to make a bet on how long this was going to last. Like what, we're all going to talk to each other, and we're going to, in the open, we're going to share our ideas, and are we kidding ourselves? Like, who are these kids from Facebook, right? I mean, Frank on the stage was by no means a kid, but these kids from Facebook are going to have us talk to each other and so on. And it turned out to be true, right? So those architects are still involved. I'm still involved. It is proven true, right? The openness, the efficiency gain from designing and collaborating in the open was simply better than going back to the world of, I can say it when Amanda's not here, lawyers and NDAs and all that terrible stuff, right? And it's been kind of amazing to watch, right? Because literally 10 years ago, the thinking was this couldn't possibly happen. It's too complicated and so on, right? All right, so I'm going to finish up. I'm going to finish up there, and then we can go into the panel. Feel free to catch me online, but then let's go into the panel session, or we'll take a quick questions as you have. Oh, you wanted to ask? Oh, I see. Go ahead.
I can ask you a question.
Go ahead.
So if I'm buying stuff, like if I'm deploying a big data center, I'm thinking about dollars, right, or pounds, and the amount of energy I'm going to put into a server over its lifetime is more than the cost of the server. So, I look at my kind of flops per watt and my dollars per flop and all this kind of metrics, and when I can buy a server that's got a better energy footprint, I throw away all that hardware and I buy another server, right? Because that's going to work out better for me. So how do we kind of change the economics about this so people start thinking about the kind of included carbon inside the actual hardware itself?
Yeah. So we can talk about the details, Andy, but I think you'd be hard pressed to find a server that has the characteristic that you described. So in our experience, my experience at IT Renew, before that at EMC, power consumption is 15 to 20% of the lifetime cost, right? It's one of the great things that the cloud bought us, right? Because Amazon made clear kind of a clear market clearing price for what things should be worth. And so we spent a lot of time explaining to our customers, how much you're going to pay for your hardware, how much you're going to pay for your things. That personnel costs can easily be had. But anyway, the point is, you'd be hard pressed to find a server where you can pay as much in energy over its lifetime as you put in, right? There is an awful lot of cost in servers, and some of it's margin, but a lot of it is technology cost. But regardless, even if it was true, right, I think the important thing, I think the point that the three of us are getting to, the point of this, is that there are some optimizations in here where you don't have to make any compromises, right? That it's not, we're not saying give up this and get this instead. We're saying think a little bit more carefully, think a little bit more collaboratively, kind of look, God forbid, 2 years down the line, 3 years down the line. And then you can, with no compromise, make better decisions, right? We can still save the world with vaccines. We can still creep on people. We can still do all that stuff. And we can do it with a lower resource consumption, right? So I'm happy to talk about it offline, but that's what the data shows.
Yes, one more question.
Again, really interesting stuff. To what extent, this is obviously a hugely general question, but to what extent do tech companies, consumers of servers, feel like they are competing on this sort of compute efficiency, our hardware is better than our competitors? Is that a thing, or are they more interested further up the chain?
So the cloud companies are seeing this, right? So I have a much longer version of the presentation where you can see that the various cloud providers are starting to differentiate based on what's the carbon footprint of my computing. Unfortunately, I think most of them are just doing it based on, is it a solar array or something, right? Not, did I recertify the server? But there are companies that are recertifying servers. For example, some have been doing it for a long time, right? We worked with OVH in France. They've been doing it for over 10 years, right? Waterfalling their servers and extending the life, right? Amazon does it to some extent as well. So I think the cloud providers are starting to do it. Within the OEM manufacturing base, it's not the first thought, right? The first thought is to sell you some new thing, right? And that's going to take some getting over. Right?
Yeah, sorry. So I guess an extension of that question would be not from the sort of doing better, reducing carbon emissions, but from the perspective of, I'm Facebook, that's not a good example to be honest, but, I'm trying to make as much profit as possible. Am I willing to take a potential, setting aside the no compromise options, am I willing to make a potential hit in, having the latest, greatest servers to take a different path?
Yeah, so I can speak to Facebook directly. So Facebook is one of the known clients of IT Renew. So what IT Renew enables is that Facebook is able to take material off the floor, reinvest back the savings from putting that back into supply chain into new servers. So they're actually, in fact, able to reduce their total footprint by participating in the circular economy. They participate in the front end rather than the kind of medium and back end. But they literally just announced last week that they're going to start running their servers for 5 years instead of 3 years. Right? So that's not so great news for the people who work in that factory, but it means that life extension is going to happen naturally, and that's really the truth of the matter. As Deborah and Astrid already said, that if you can run your server for 5, 6, 8 years instead of for 2 or 3 years, then that significant amortization of that embodied energy is right there. You're preventing some new motherboards being made in Taiwan, but it's probably okay.
Thank you.